so I got to go do that.
All right, well, I'll be over in the morning. Maybe
Okay.
after you've gone, but see you sometime.
Good enough. Thanks. Bye. Yep. Anybody home there?
So here's the thing. The way this is set up, we're not talking the lights. So Jordan's got a light up here. We're gonna fix this out next time, but we're gonna have to degree anybody else can hear.
How you doing, Greg? Can you hear us?
Yeah, I can hear you. I don't see anybody else, but I can hear you.
No.
Ah, there you go.
What's it say under participants here?
Yes. Just let me, roll call here. Ready? All right.
Hello, Jordan. Jordan, Zoom says you're muted.
No, I'm not using the. I'll tell you what, Jordan. Jordan, if everybody just record down, Jordan right over there, he can speak into the mic. I'll try to- Everybody carry on.
I thank everybody for working with us through these technical difficulties. It's like our bald heads are the only thing I'm just.
Hey,
All right. Glad I shined it for today. It's gonna get a view. Buffed it. I will introduce in 1 second. Thank you, everybody, for coming here this evening. County Board of Supervisors and the Rockford County PSA Board. I'm Jordan Combs with the Mortgage Service Authority, the Executive Director. And today we have the engineering firm here with us to help go over the water treatment facilities assessment study that was conducted for the Mortgage Service Authority. So today, I think here we've got the Rockbridge County PSA Board and the Rockbridge County Board of Supervisors here with us. So I'm going to start off with going over we're here today to talk about the water treatment facilities. Yes. So George Rest is with the engineering firm. I'll go to that page. I was going to introduce in a minute. As you can see, George Rest is drinking water specialist with Rambo. I also have here today Matt Wimmer with Rambo as well, the project manager, who will also be doing most of the presentation today. And then we also have PJ Crow is part of the team working on it, but he's not as part of that presentation as we have today. I think in the audience here today, I think as part of the question, looks like we have William Johnson with the Mortgage Service Authority, the Operations Support Director, Chief Engineer. We've got Debbie Desjardins, the Administrative Resources Manager for the Mortgage Service Authority. And then I don't know if we need to introduce the rest of the team. We got Ms. Stewart with Rockbridge Area Conservation Council. And then I think we have they wanted to come down and watch us give this presentation. So, but I'll see if I can back up here. Not a problem. So the agenda today is to talk about some of the project objectives. Talk a little bit about the background chronology, some of the key events and things that have happened through the Mortgage Service Authority to try to work us through what we've gotten to and where things are today for the Mortgage Service Authority and the water treatment facilities. Then we're going to talk about the key findings from the assessment. And then we're also going to talk about then the recommendation next steps and kind of review those as we go through. I think the point of today is to try to have some informational dialogue and start the dialogue with our customers. We've already had the same presentation with the City of Lexington, and then we're also having this joint meeting tonight. The intent is to talk about what we're finding and kind of how things are going to go forward. There's no intention of asking for anything today. It's mainly for informational purposes, and we're trying to work on having some better communications to our customers as things come up and as we work through these. I think everybody's had dialogues and at least heard through some version of what things are to come, but that's what here is to talk about is the work that needs to be done. So the project objectives. So the Mortgage Service Authority started off on and working through the water treatment plant and associated water facilities. So the evaluation and the purpose of having the facilities assessment is to help us get our arms wrapped around both on the water and the wastewater. And tonight we're talking about the water, the things that need to get done to help us get our facilities to the point that they're maintainable. I think a lot of things that you're going to hear tonight and things we're going to walk through are going to work through things that have run to failure or are past the point of running to failure. One of the things that the engineers will say, and when you read the draft report or read some of the reports we have, they'll use terms like past the useful life expectancy. And really what that means is it's running to the point of either it has failed or it's about to fail. I think when we talk about things of these facilities, in particular on the water plant side, some of these go back, and a lot of the equipment and things that we have go back to the original 1975 construction. Some date back to the 1936 when the town of Lexington built that raw water pump station and then built the old water treatment plant, but there's intake and things of that nature. And so I think as we walk through today, we're trying to get our arms wrapped around so then we can start laying out the work that needs to be done to fix all of the known broken things, the upcoming broken things, and try to move past the firefighting stage that we've been in and work towards a proactive step of trying to get our arms wrapped around it. But that first step is understanding what do we need to get done to get to the point where we have maintainable system. After we go through the assessment and we've gone through an assessment of the condition and the capacity of the facilities, and the other part of it is to identify recommendations for the approach and the improvements where needed. Now, this is not just the water treatment plant. We're going to talk today. It is the entire MSA water treatment facilities. That includes the raw water pump station. So how we get it out of the river, then how do we get it through the treatment process, and then how do we get it through our transmission and storage that then ultimately our two customers, the city of Lexington and the Rockbridge County PSA, pull off of that transmission line. And so it's everything from when we pull it out of the river to where the connections are of our two customers. It's a little background. Already talked some about this. Around the 1930s, the low dam and the intake was constructed by the city of Lexington. But then when the Maury Service Authority was founded in 1970, to serve, sustainably provide clean water for the public health and safety of the general welfare of the communities we serve. In 1974, the 4.4 million gallons a day water treatment plant was built, along with the new raw water pump station, and the infield storage tank was built in that time frame in the 70s and the 80s, and then they began the construction of the loop. In 1989, one of the things we're going to talk about today is the structure at the sedimentation basin. So when you go to the water plant, big concrete tanks that connect to the side of the building, there's a lot of infrastructure, there's a lot of structural integrity issues with that structure. In 1989, the structure was failing at such a point that there was reinforcing steel on the outside and I-beams to try to support that structure. In 1983, what's not up here as well, was it was leaking so bad that they had to put a liner in it to keep it from leaking. This is all within 15 years of the construction. 2003, there were upgrades done to the water treatment plant, mostly modifications to some of the processes, under drains of the filters and that kind of items. And then, of course, trying to, again, patch and repair some of the structural issues on the sedimentation basins. In 2012, the infield pump station was constructed and the loop was actually finished. That project was a Maury Service Authority project, but it was done by Hurt and Profit, the engineering team, and then constructed and finished in around 2012. That essentially, one of the things as we go through today and we look at the loop, that's the MSA's transmission main that essentially goes around the city. You'll see some pictures of that and we'll talk about that as we go through, but it was finished and actually connected as a loop in that time frame. So then we find ourselves at where we're at here today in 2021, 2022, conducting the facilities assessment, and we're having that presentation to you all this evening. I've already introduced the engineering team that we've had earlier, but I'll go ahead and reintroduce Matt Wimmer, the project manager for Rambo. Rambo was previously O'Brien and Gear, and now as through acquisitions, their name is Rambo, but that kind of gives you some background of them. And so with that, I'm going to go ahead and hand it off to Matt Wimmer, and we'll present from there. One thing I would like to add actually before I hand it off is this open discussion. We have it set up. We're trying to roll through the slides, but if there are questions, feel free to raise your hand. We'll try to get a mic to you. And then that way you can ask the questions as we go along, as opposed to trying to hold them all to the very end. There's a lot of information we'll be going through today.
Jordan, I will say, for anybody who can't see me, it's Spencer Sear. If you do have a question, just for the folks that might be looking at this later or viewing it right now, just let me know and I'll get the mic to you.
Thank you, Spencer. With that, I'll hand it over to Matt.
All right. Thank you, Jordan. Just like Jordan said, I'm the project manager for Ramble Engineering. We have George Rest on Zoom. He's a vice president and subject matter expert on water treatment. I guess before we jump in, like Jordan said, the scope of the project for us was to come in, assess the water treatment facility, come up with recommendations on what improvements might be made, and then helping to come up with a path forward on how to implement those. Some of the stuff I'm going to cover is going to be high level. Got a lot of slides to get through. Need to take a deeper dive, jump in, let us know. But I guess we'll go ahead and get started. So the first image on the screen here, the red line you see going around the city, that is the loop, the transmission loop. The portion of that line that if you can see it, it's highlighted in green. That is the portions that date back to the mid 1970s. In the sort of the northwest corner, it's tough to make out, but you see a pin, that's the raw water pump station. A little ways south of that, that's your water treatment plant. And then about a mile to the south of that, as the crow flies, is what we've been calling the infield remote clear well, or the infield tank, and the infield pump station. So just to give everybody some frame of reference on where these facilities are located. The next slide, this is a process schematic of the water treatment facilities. As we work our way through this presentation, we're going to start at the Maury River and then work our way up to the raw water pump station, into the water plant, and like Jordan said, out to the infield remote clear well and into the loop. We have a red box drawn around the rapid mixing, the flock basins, and the settling basins. And so you're going to hear the term pre-treatment process or pre-treatment facilities as we work through this presentation. And just wanted to, I guess, note that when we say pre-treatment, really what we're referring to is the rapid mix, the flock basin, and the settling basins combined. So in the way the presentation is structured, we're going to hit you with a lot of, quote, the problems or the issues that we identified. And then we're going to step through those same unit processes and give you sort of our recommendations, the improvements, and the conclusions, and sort of the next steps. So jumping in with the raw water intake. So again, just an aerial to familiarize everybody with where we're at. You can see the raw water pump station down the Maury. You got the raw water intake, and then the pump station adjacent to that. So start with the intake. From a capacity standpoint, we found that the data supports that the existing intake can withdraw 4 MGD. The wastewater plant is permitted for 4 MGD. In terms of its condition, so this is one of the facilities that dates back to the 1930s. So it's, if not the oldest, it's one of the oldest pieces of infrastructure the MSA owns. But the bigger, I guess, a bigger item is that it's very labor intensive. It requires manual cleaning, which requires frequent maintenance. It's more problematic in the fall, and also when during, say, rainstorm events, when debris is heavy, and or when site access may be limited. So I guess to getting back to its age, one of the issues associated with its age is that it's unpermitted. So any intake that was in existence prior to July 1st, 1989 was grandfathered, which meant that it didn't require a Virginia water protection permit for the intake. And where this comes into play in this assessment is if the MSA wants to do any type of maintenance to that intake that would require them getting into the river, they would have to get that permit first. And so fixing that intake in the screen is a big issue, but right now that can't be done because of the permitting concerns.
Or the lack thereof of a permit, period.
Yeah. For the raw water pump station, its capacity. So we say its connected capacity is 4 MGD. We caveat that with the fact that that means that all pumps in the pump station are running. So there's 2 pumps installed in the raw water pump station. You need both pumps operating to get 4 MGD. Based on Waterworks regs and current code, in order to really claim 4 MGD of capacity, you need a third pump or a redundant pump. And there currently isn't enough space in that pump station to fit a third pump. And so anytime one of those pumps go down, the MSA's actual capacity is effectively cut in half, say 2 MGD. In instances where power is lost at the pump station, there is no backup power. And so in those instances, a portable diesel pump has to be brought to the pump station, and that pump is only capable of pumping 1 MGD. So in the event of a power loss, because there isn't a backup electrical power, the capacity is cut by 75%. So jumping into the condition, again, the electrical equipment's all 1975 vintage. It's well beyond its useful life. And it presents, I'd say, both risk for sustained outage, which the MSA experienced a couple of years ago, as well as safety concerns. Similarly, the pumping equipment is beyond its useful life. And I believe the MSA has already replaced one of those 2 pumps. In addition, the stairs in the electrical room don't meet current code. So if you wanted to make any electrical improvements to the pump station, you would have to actually expand the facility because the current electrical room is sized too small for current code. A couple other items. The pump station is located within the 100-year floodplain. For staff, during flood events, it can't be accessed. It lacks the ability to feed some chemicals, pre-oxidant, which would help with or would help to enhance water quality. And again, touching on the lack of emergency power supply, there is no backup generator on site, and there's limited capability currently for remote control and observation.
A couple things I want to go ahead and add at this point to help connect some dots. So we got a backup pump, 1 MGD, no backup power. The other thing is we also lose access during, it's not just flooding as in the community's flooded. We actually are finding ourselves on an annual basis not having access to that pump station because it turns into a moat. So it may not get flooded and the floor get wet, but the way it's built and where it's located, we can't get access to it during heavy rain events. So when we find ourselves in that situation, the majority of time we lose power are during heavy rain events, those types of storms. And so we can find ourselves in situations where not only do we not have backup power, are we limited in that backup generator pump, but we also don't have access to even run that generator pump during those high rain events. And in addition to that, even in the situations where we have the access, we're reduced to a quarter of the capacity of what's required. To kind of give a perspective, our current demand is around 1.5 million gallons a day to our 2 customers, split roughly either in the 50-50 or 40-60, depending on how things are between our 2 customers. And what that means is that if we have a prolonged scenario, even if we can put the generator pump in place, we're looking at a losing ground type of scenario. So once you start to lose that ground, you're not going to be able to make it up until we resume the power capabilities. On an average daily flow, correct. There are times that we have a daily flow that's higher than 1.5 million gallons a day, but that's dependent on the demand. But when you add up what we have and divide about 365 days a year, then it comes out to about that 1.5 million range.
But I just was asking 1.5 million for your 2 customers, but you said each pump, both pumps, it's 4 MGD. So each pump would be 2.
Correct.
So even if you were down 1, you should be able to meet.
So that's a good question. So that's able to meet current demand. One of the things that when we talk about the health department regulations that Mr. Wimmer has mentioned, when you look at our engineering sheet to talk about what the design capacity of the plant, where the health department gives us permission to say how much water can you treat, it's based on certain amounts of redundancy based in it. And so one of the conversations that's on an ongoing dialogue with the health department is they want to derate the facilities to 2 million gallons a day because of the point that you just pointed out. And so right now we have current agreements with our customers, the city and the PSA, that half of the capacities go to those 2 customers, whether it's the wastewater or the water. And so the expectation is there's 4 million gallons a day capacity. And the way it's currently set up, I think what we're saying is that there's not 4 million gallons a day capacity. And the health department is pushing us to derate the capacity to 2 million gallons a day based on the fact that we aren't meeting that redundancy requirements.
And I guess just one item to add. So it produces on average 1.5 million gallons a day. But when the plant's running, the rate, it's actually an instantaneous rate. It's producing 4 million gallons a day. The MSA currently operates with one shift. So 8 to 10 hours a day producing water at a rate of 4 million gallons per day. So if you take 4 million divided roughly in half, a 12-hour shift should be able to produce 2 million gallons of water. So if we were in the MSA was in an instance where the pump station was derated to 2 million gallons a day, they'd have to operate, say, 16, 18 hours a day to produce that 1.5 instead of the current one shift, 8 to 10 hours. So derating the facility, smaller equipment, slower production, would
Longer
have
hours.
longer hours.
What is the storage capacity?
So it starts to get a little complicated in the storage capacity, mainly because our storage capacity reaches out to our two customers. So when you start to look at storage capacity, you got to take into account the Grassy Ridge tank, which is a PSA tank. And then you take into account the Houston Street tank. And then you take into account our infield tank. And so our infield tank, one of the things that's not in this presentation, but is in the report, is that even though it's a 3 million gallon tank, we only have about access to around half of that in any moment due to the fact, because of the way it was retrofit constructed, we start to see cavitation in the pumps when you get below the 15 feet of that 30 feet available volume. And so we've run it down to 12 feet, but that causes problems with the equipment when we were in a scenario. So a quick way of looking at it is we have about 1.5 million gallons in our infield tank, which is about a day's worth of capacity at infield. Now, how much, then you start to have to look from a hydraulic perspective, what the PSA Grassy Ridge tank is. It's at the highest point at the elevation. It's going to be the first thing to lose water when we get to that low point. And so then there may be people inside the city that have water longer than people out further in the county that get that water. But in round numbers, you're looking at a day or two capacity of what's in that, what's in the system without having to run a hydraulic model of both the systems combined to see what that would be. But when you're talking about 1.5 million gallons a day, we got about 1.5 million gallons in the infield tank that's available. So that's roughly the storage we're talking about. It's not measured in weeks or months, it's measured in days when we start to talk about how much storage capacity we actually have.
All right. So just some photos to go along with what we found. The first photo, that's a damaged 3-phase circuit breaker. This is one, so when we talk about run to failure, I think it took the MSA a week and a half, or it's over a week, to go and find the circuit breaker. I think it's 1975 vintage. So it's not something, it probably hadn't sat on the shelf since 1980. So week and a half just to find the part. Luckily they found it, we're able to get it installed. But this is the type of thing that you can't run to failure. You run this to failure again, maybe you're looking at, again, completely rebuilding your pump station where it's at because of code requirements. Middle picture, damaged switchgear bus. This currently remains in service.
So that bus bar is where the old breaker connected into it. That's the main electrical panel in the raw water pump station. So I think where this is a run to failure discussion, even though we all agree they don't always make it like they used to, and so things can run a good while, we also run into a situation where if our electrical contractor didn't have a one that they found used in their shelf and we didn't happen to have one sitting on the shelf from 1975s, we had spent a week and a half looking, and these are 4 generations obsolete. What that means is that they don't make it anymore. You can't buy it on eBay anymore. You can't repair those things. And where that starts to run into an issue is on something like the raw water pump station, only raw water source we have. because of the electrical codes, if we had to rebuild, if we have another failure with these breakers and this main bus bar and this electrical panel, we're going to have to build a new panel to meet the new codes. We don't have enough room in the building to meet the current codes of putting in a new panel, which means then we got to expand the building in an emergency situation, running off of some type of diesel pump until we could expand the building to get to the point that we could then put in a new panel, to put in the new breakers, to hook up to all the rest of the stuff that's still 1975 vintage. And so I think it's just a good example when we start hearing run a failure. I just think it's a good visual and example to have that these things exist throughout the facilities. We're not just getting rid of old things because we don't like old things.
So this image here, I'd say the main takeaway here is plotting the 100-year floodplain on current aerial, aerial image. The green star, if you can see it, here, that's where the current raw water pump station sits. And so when we start looking at what alternatives do we have, we understand that probably rebuilding the existing pump station, it can't fit in its footprint. Do we build back within the floodplain where it's at? Or do we start looking at, well, let's take away some of those risks like the access, the backup power, and consider relocating that raw water pump station outside of the floodplain. So the two main alternatives that we took a look at was upgrading and expanding the existing raw water pump station. Doing that would address the deficiencies with the electrical, allow us to build the larger room, bring it up to code, replace the stairway with something that provides the staff with better access. We replaced the pumps, the MCCs, expand again the building enough to fit that third redundant pump, and bring in remote controls, SCADA, instrumentation, and expanded enough where we could fit a pre-oxidation feed system. But the issue with that is that, again, we're still in the floodplain. And so do we really make a significant investment in a new piece of infrastructure and still keep it in the floodplain? Our recommendation is no. Our recommendation would be to demolish the existing raw water pump station and build that new pump station outside the floodplain that would allow us to bring standby power to the building, and it would address the existing risks that we identified during the condition and the capacity assessment. I guess moving on to the water plant. Again, here's the flow schematic again. So we'll be starting with that pre-treatment process, work our way through the filters, through the clear well, and then out into the system. So aerial image again. So raw water pump station down here by the river. Come up this access road. You have the water plant sitting off of Osage Lane.
Yes.
Control building. Here's the sedimentation basins. This is that pre-treatment process. And then over here we have the MSA's 2 lagoons.
Just before we move from that, we're going to talk a little bit later on the lagoons and the drying bed, the 2 big round objects on the left, oblong. Those are it. The one on the south side of the picture, the bottom of the picture, that's the actual lagoon, line lagoon that was lined in around 2005. And then the other lagoon above it, that's full of the brown part, we call that the drying bed. That was retrofitted, not an engineered system. It was a MSA city employees figuring out how to try to get the DEQ to stop asking questions. And so they kind of put something in place, and we are struggling with that on a regular basis. And I think, part of that issue is the fact that we don't believe it was actually an engineering design system to try to do what it was supposed to.
So from a performance and capacity standpoint, talking to performance, the existing treatment processes are producing high quality finished water. So, a lot of what we're talking about, we have equipment that's aged And we need to acknowledge that and understand that at some point, those are more likely to fail than something that's new. But did want to point out that just because of the sort of the deficiencies that we're finding, that doesn't mean that the MSA is not meeting its permit. It's not producing quality water.
But it does mean that we are fighting very hard to continue to do that. There are multiple examples where it's always all hands on deck 2 or 3 days, where everybody, including the executive director, myself, is out there with steel-toed boots getting things fixed.
From a capacity standpoint, VDH has rated the water treatment plant processes for 4.4 million gallons per day. But we actually, as part of the capacity assessment, we did some hydraulic evaluation, some tests at the water plant. And what we figured out is that there's a few hydraulic bottlenecks within the systems, within the filters, to where at any given moment, the MSA is 3.4 MGD is really about the max that the water treatment plant process can produce on an instantaneous moment.
Which is actually what we currently operate the facility at. 3.5 million gallons a day, 10 hours a day to meet our current demand.
So in terms of the condition assessment, starting off with that concrete structure, the pre-treatment process, the sedimentation basin, we had a structural engineer come out, spend 2 days evaluating these basins. We actually spent 2 basins parallel to each other. MSA operates them as one single basin, but we isolated them and completed an assessment. Found several structural deficiencies with that basin. Some of these pictures show the issues. You can see you got some spalling concrete, some cracks. This is a walkway spanning that building. It's probably tough to see, but the concrete is delaminating. And while that may appear superficial, the concern is you're getting water's getting in from the top, and you also have these lines you see in this third picture. That's exposed rebar, and so this one particular walkway, our structural engineer was so concerned that the MSA has actually cordoned off that recommendation was to not have staff use that walkway.
It was unsafe to walk across. So there's 3 walkways that we've had to do that to.
You can see this looks like a metal pipe spanning across. This is actually one of those structural supports. What you'll see here in a minute is there's an I-beam on the outside of these walls. And these steel members are tied to those I-beams. Really what it's doing is it's trying to keep those outside walls from trying to bow out. And it's sort of pulling them back, trying to keep it in tension. And that was the repair that was made in 1989, approximately 13, 14 years after this tank was constructed. Again, here's some more concrete deficiencies. I got a big crack in the wall here. This is a picture that I-beam was talking about. There's that steel member spanning across to keep the outside walls in tension. Another issue with the walkway, the underside. And then here, looks like a crack, but the bigger concern from our structural engineer standpoint, that the dark spot, that's water. And so what that means is you have a crack that goes all the way through the face of that concrete. And you have water getting from that inside face to the outside face. And as it's making its way out, it's also getting into the rebar within the wall. And so again, it's not just a superficial concern. It's a significant structural concern. So these are just bullet points of pretty much what I just went through. The original design required that additional steel framing, which you can see in that middle picture. We had cracking, joint separation, and spalling. It's indicative of whether it was poor materials or poor construction, workmanship, or both. But those repairs had to be made within 15 years of that original construction.
And I think when we say original design required addition of steel framing, that doesn't mean that the steel framing was a part of the original design. I think what it means is after the engineers, the way they explained it to me is that the way the walls and the floor were built, they were not built in a situation to be able to be empty and full. They were only built to be in one condition or the other. And we have to actually have these full when we're making water, drain them when we're not, and clean them out when it's time to clean them. And so those conditions require that scenario to happen. And one of the things he pointed out to me is as we walk on the walkways, there's several areas where there's these two pieces of metal on a construction joint, and they are off probably about a half an inch to 3/4 of an inch. And he pointed out that was where monitoring had happened of how much the walls were moving. Now, on 3/4 of an inch, I grew up a sheetrocker's son. That's close enough. But when you're talking about movement of a wall, it's not supposed to be moving. 3/4 of an inch is a lot, which is why the members had to be come in to keep the walls from falling down.
So what's the punchline, right? Patching these deficiencies, that's not a permanent fix. It's a Band-Aid. And so at some point, this structure has to be replaced. And so you can continue sinking money into a bad investment, or do you start looking at, well, if we're not going to continue to try and fix what's there now, what are the options? And so in a few slides, we'll run through what some of those options are. Continuing the condition assessment throughout the facility, the main building structures, generally in good condition. One of our concerns is that sedimentation basin, it shares a wall with the control building. And so knowing what we knew about the other three sides of that basin, the concern was, well, could that be affecting the building itself? Our assessment is no, that wall was in good shape. We completed a rover inspection of the clear well. And again, that only showed minor spalling and cracks. So sort of going back to that was another area we wanted to look at to see, did the same workmanship or materials issues that we saw with the sedimentation basin, did that extend into the clear well?
And so everybody knows what the clear well is. When you walk up to the building, you look at 3 above ground floors. There's a below ground floor where the water, after it's treated below ground, that clear well is where the water, after it's been treated before we pump it out, that's where it sits. So obviously we wanted to make sure that wasn't an issue, because that could be even more of an undertaking. And I think the rover that we put in is basically a robot, submarine robot they put in the water, swam around to look at all the structures, and then brought it out.
Continuing on to the process equipment and the power. Process equipment is generally functional, but again, the equipment itself dates back to 1975. And so while they're functioning now, I guess our recommendation is the MSA should be making a plan to replace those, because assuming that they're going to continue to function for another 50 years, it is probably not a good bet. For the chlorine system and some of the finished water pumps, we did note that because of their age and their typical wear and tear, they are beyond their expected useful life. And so might want to make a near-term plan to replace those. Electrical and power supply. Relatively modest list of recommended improvements to the distribution. Our electrical engineer found those to be in good condition. Maybe the biggest deficiency that was noted is that the on-site power generation, the backup generator, the emergency generator, it's not rated to operate at full capacity of the water plant. It only provides enough energy to produce 1 million gallons per day. So that would be running the plant 24/7. You can squeeze out 1 million gallons per day. In periods where you're only out of power for a few hours, no big deal. But when you have a true emergency like the derecho back in 2012, when you're out of power for days, that's where not having the system capacity to provide water to meet everyone's demand for an extended period of time, that's when you probably ended up in a letter going out asking people to conserve water. These are just some photos. Scott had some exposed electrical wiring, notice of corrosion on the filter panel. Rapid mixer. This is equipment that dates back to 1975. The sodium hypochlorite system and the soda ash loading, soda ash hoppers in the 3rd floor. Main reason we're showing the hypochlorite and the chemical on the 3rd floor is because the MSA currently does not have an HVAC system on that 3rd floor, minus the box fan that you see in the window. From a water treatment plant operation standpoint, the HVAC, that on the 3rd floor is not there to provide AC and comfort for the humans. That's to prevent corrosion, like you see in the picture. That's to get adequate ventilation and airflow through that, through the 3rd floor. That is typical. That is expected at most facilities, at all facilities.
So fluoride and sodium hypochlorite, chlorine, strong bleach, both of those chemicals are highly corrosive and dangerous to the staff. So in any standards after 1970s, they would have had adequate ventilation system to keep that air moving and air turnover. So that way you didn't have issues and safety concerns with the staff. And so that 3rd floor is also a storage area. So even when we store the 3rd pump for the raw water pump station up there, in about 3 months, it's covered in rust due to the corrosion, which obviously then there's health concerns.
Then one other item to note on the instrumentation and control on the SCADA side, that equipment is aged, it's obsolete. And so as the MSA, if we start moving forward with improvements, our recommendation would be that those new systems should be implemented and tailored to the upgrades that are identified and built.
And the SCADA that we have was put in as part of project of finishing of the loop. And essentially what it's there for is help us monitor the remote pumps and collect some of that data. There's no control from it internally inside the building, and there's no communication to the raw water pump station on any of the activities that's going at the raw water pump station.
Some other improvements to the lagoons and the drying bed. Like Jordan said, the drying bed is a non-engineered improvement that was previously made. And so recommendations would be, with how problematic that is for staff to maintain, install an under drain in lagoon number 2 for the drying bed, and to replace the splitter box. And then also currently the effluent that leaves the lagoons, I think it actually goes to a sinkhole. And the recommendation would be, while you are improving the lagoons, that should be piped to the Maury River.
Discharging 250,000 gallons to a sinkhole is not a good idea from a structural standpoint. It's something that DEQ is not happy about, but it was put in our permit in 1975. And so they haven't told us that they're going to remove that as with a discharge location, but it is an area that we have gotten several letters on the past saying this is a concern of ours. So not only do you run the risk of making the sinkhole bigger, there's also other health concerns that DEQ has in sending that water and discharge water into the ground.
Filter backwash supply pump, talking about critical assets. That's currently the only pump that is available to backwash the filters. It's an original pump. And so recommendation is either figuring out, making improvements to the clear well in order to install a second pump, or having a second pump on close standby to replace this one when it fails.
So Lagoon 1, it's got a liner on it, and its purpose is more to take the water, and it's where we discharge. We don't have any current issues with it, but when the time comes to design the drying bed and deal with our waste system, and then we got to find out how to get it to the river, that's going to have to be a part of the discussion on how to handle that scenario.
So sort of going back to that sedimentation basin, what options are out there? It's really three. You can replace it in kind. So come back with a structure that is similarly sized, that treats the water in a similar manner, similar rate. The second option is it's a similar pre-treatment process, but it treats it at a higher rate, which means you can go with a smaller footprint for the structure. Then the third one would be to replace what you have and go with a completely different treatment process. For instance, maybe switching to direct filtration membranes. The key there, though, is when you do a wholesale treatment overhaul, you're going to need to prove to VDH that you could do that and you're going to be able to meet your permit. And so if you made a wholesale change to your treatment process, you may be looking at some pilot or bench testing over some water quality conditions to figure out, are there other unit processes that maybe you need to add to that in order to produce the water quality that you want to produce. So I guess the last one of the condition capacity assessment, we're now, the water is leaving the clear well and it's being pumped. It's pumped up to the infield remote clear well, infield storage tank, and then out into the loop. So again, if you can imagine the water plant sitting off the page up here, and you have the infield tank, remote clear well, about a mile as a crow flies to the southwest. Then you have the infield pump station. Not too far from Kendall. So as part of the facilities assessment, we brought the rover out to the remote clear well to complete an interior inspection similar to what we did to the clear well at the water plant. We also completed an exterior inspection. And so what it found is similar to the water plant and the equipment. For its age, it's not too bad, but it hasn't been maintained. It hasn't had any rehabilitation done to it. And so there is a list of improvements that need to be made to both the exterior and the interior in order to maintain the longevity of that tank. For the infield pump station, I think that's probably the newest piece of infrastructure that the MSA has. So it's in fairly good condition. I think the one item we noted was replacing the existing monorail with a traveling bridge crane to provide ease of operation and maintenance and to help with safety concerns for MSA staff. With the loop piping, the MSA has started replacing the pre-1976 loop piping. I think they've replaced about a half a mile here recently, but there's approximately 2.5 miles remaining. And so the recommendation would be for the MSA to continue with that systematic replacement of that aged pipe. That aged pipe, for the most part, is either cast iron or asbestos cement. I think some might be ductile, but it's all getting on that 50-year mark of being in the ground, and that's starting to get to the point of needing to evaluate and consider replacing those before you have breaks.
We've already had breaks in both of those aged piping, the cast iron in particular, and the asbestos cement pipe. There's a reason that in the 1970s, asbestos cement pipe stopped being used along with cast iron due to its brittleness. One of the things that happens with asbestos cement pipe is not only does it have asbestos in it, but it also is very brittle. Right now, there's a lot of instances where when you have this age of the asbestos cement pipe, a lot of times the ground that's around it is providing more structural integrity of holding that pipe together than the pipe itself. The other issue that we have found in the recent break that we had on Furs Mill, that the PSA and the City of Lexington Department of Public Works helped us significantly get that repair. A lot of help from both of those groups. We found that pipe, that's the cast iron pipe that was put in, was not rated for the current pressures that we're seeing after the loop piping was finished, which is concerning.
And then I guess the last recommendation coming out of the loop analysis was that the MSA currently doesn't have a hydraulic model. And so in order to evaluate some of these operational and potential water age concerns that the MSA may have out in the system, the recommendation is to go ahead and let's put a model together and get a good idea, get a good feel for how the system operates, how the MSA is providing water to its customers. And this is, again, just an aerial image of the loop system. There's lines shown in green. That's that 2.5 miles that we were discussing, going from the water plant across Maury River, heading east along Furs Mill out to Route 11, and then going from essentially from just south of Route 60 to the Houston Street tank along Route 251, or adjacent to 251. So I guess getting ready to move into sort of the recommendations and next steps. Any questions before I jump in?
So Greg probably can't hear. Greg, can you take over his chair? Still with us?
He's muted. He's trying to unmute.
Yeah, I'm unmuted. No, I could not hear the last question from whoever.
It was Mr. Mast has got to step out, and so he's chair, and he's asking if he can pass the gavel virtually.
Yeah, yes.
Okay.
Yep.
Thank you, Greg.
I'll be right here.
All right. So starting with the intake, conclusions, not to be obtuse, but the intake's aged and it's unpermitted. Those are the two challenges that the MSA faces as they move forward. And the other item that's not written there, but it's in the white space, is it's a pain in the butt to maintain. And so because it's unpermitted, they currently can't fix what's aggravating their staff. The water protection permit from the DEQ is necessary in order to replace or significantly modify that intake. And then the other sort of caveat that goes with that is because the MSA is currently producing, on average, 1.5 million gallons per day. When you go to get that permit, they may not support the MSA's intent of withdrawing up to 4 million gallons per day. So what does that mean? The MSA has an aged intake that's problematic to maintain. In an ideal world, they had a permit, they'd be making repairs to that, right? So our recommendation is to move forward and start a dialogue with DEQ. The MSA has started that discussion because the intake's still functioning. It's a pain in the butt, it's problematic, but it's still functioning, right? What we don't want to do is get in the situation where something catastrophic happens to the intake and the MSA is forced to go in and fix it, repair it. If you're going to DEQ because something's broken and you have to get a permit, you may lose some of the leverage that you may have right now, having the discussion with DEQ to understand what their requirements may be to get the permit. And so let's be proactive in those discussions, see where they take us before we find ourselves potentially in a situation where we're having to talk to DEQ because we have to make a significant repair.
And one thing to add in that this dialogue with the DEQ is to help us understand what are you going to ask for, DEQ. And so part of what ends up happening in that information and dialogue, a lot of us look at it and go, you got so much water going by. Am I taking out that much water? No, we're good. The DEQ looks at it from a perspective of who's downstream that's going to try to have access to that water. They're also going to look at integrity of the distribution system. So we have to have a dialogue with our customers, because one of the things that they're going to ask in that is what is your, basically, how leaky are your pipes when you go and distribute it? And so that's going to play into a dialogue. They're not going to want to give higher intake water coming out to people that have leaky pipes unless there's a plan in place in fixing those leaky pipes. And so we're going to start to have a discussion of if we go, right now, we're just trying to have if we ask for it, what is that information going to need? I think the other part of that is that they're going to try to look back on the history and say from 1989 going backwards, how much water have you used? And I think part of our discussion is we're trying to figure out how to then have a discussion of, we've got communities that are building the community around having 4 million gallons a day available to them. And so we are going to have to turn and probably talk to the county and the city to start having discussions. It's not just who do we have in the books for signing up in 2 years businesses. It's what's the zoning discussion? What are the parcels discussion? How much build out have you put in the ground infrastructurally? And what is that planning to try to use those types of things as arguments to try to understand if we can get that quote 4 million gallons a day number to be able to maintain what the current expectations are. So as we get into that discussion, I'll be reaching out to the groups, trying to understand and try to get those answers.
So why, I'm trying to understand, why do you think the state would be reluctant? Only because we haven't been using 4 million gallons a day, or because of past trends?
All the above. And when we start to get into that, they look at it from an aquatic life standpoint as well. So it's not just what people we're stealing water from downstream. They start to try to understand what is the ecosystem that we're going to interrupt if we're pulling that 4 million gallons a day out. And so that starts to get into their analysis. And so one of the things we are trying to discuss is who else are they going to bring into this permitting discussion whenever we decide to embark on it. And you're going to have, DCR, Corps of Engineers, and a lot of the other environmental groups that are looking at more than just how much water is going past us in a dry spell, and is that enough for us? And I think what's gone on since 1989 is that they've tried to use that as a discussion and the ability to try to be better stewards of the water. Examples I've run into before are they put requirements on communities to have reuse water for their car washes. Try to find other ways to use less water, in their distribution systems. And so feels a little backwards, but if you're being good stewards of water, they're going to allow you to get more water out of the river. And so, but that
Doesn't seem backwards.
Another way to look at, just because you currently have or expect 4 million gallons per day doesn't mean the DEQ doesn't look at it as you're entitled to it. You had it before, you still get it. You had it before because we didn't put these regulations on you. Now help us understand why or why you need 4 million. Yep. It can't be because, we're expecting growth in 50 years, right? If you could prove, hey, we got some near-term growth and we need X amount of gallons, they'll consider that. But they're going to start at, currently you're at 1.5 million gallons a day. Help us understand how you get from 1.5 to 4.
And the reality is that's going to come into a discussion when it comes to alternative water sources. And it's also going to come into a discussion to where if we understand, are we able to make the argument and get the capacity that we are expecting to get and want to get? If we aren't, then we have hopefully time between now and then to be working on what some of these alternative water sources are, and whether that's another ground source or another surface water source, or if that's another ground source. That's what's going to have to come out of that if we don't think there's an ability to get the permitted capacity out of the river that we want. But use this time while we're not in an emergency situation to understand what those requirements are.
As opposed to being in a situation where you have to go and make improvements to the intake because of some failure, and potentially the DEQ caps you at 1.5 because you don't have any backup information to argue otherwise. So that's where we sort of come from with, let's talk to them now when it's not an issue, than when we're having to come to them with a hat in our hand.
I agree with you on that, but you know, as we're part of the county's priority right now is economic development, and we're talking to businesses, they're wanting to know what our capacity is. They're wanting an increased capacity from the county. So just because it's kind of a chicken and the egg type, you know, I understand what you're saying. If you've only used $1.5 million, but we may be talking to businesses where and we may not have a signed contract or anything else to say it's happening in the next year or two, but we have to have those discussions, and we have to have the capacity in order to attract those businesses.
Correct. And we realize that, and I think that's why we're having the dialogue of, we got to have the redundancy. We got to understand when we go to make improvements or apply for the permit of this raw water pump station, or excuse me, of the raw water intake, we have to understand what that's going to be and try to have those arguments. That type of information is going to become critical, that's the dialogue, and that's what's happening to then be able to talk to the DEQ. If we find in this dialogue that the DEQ says, no matter how much, you're only going to get, pick a number, 2 million gallons a day out of the river, that's when the MSA is going to have to start looking at an alternative water source to be able to supplement that while we still have the ability to pull out what we're pulling. Because if we wait to have that discussion when the infrastructure fails, then we aren't going to be in a place to be ready to make that change. And so we've got to use between now and whenever this 85-year-old piece of structure fails on us to get to that point to be able to maintain this 4 million gallons a day that we have allocated. So right now we've already started. So one of the things when we get to the end of this, we'll talk about what the MSAs authorize the team, the staff to go move forward with. So we've started having that discussion with them. If we were to find ourselves in a day that we go, we're ready to ask for that, you're looking in the 6, 8, 9, 10 months range discussion from when we ask for it to when we're having a get all the information we need together to then have that. I think at this moment, we're not trying to ask for it. We're trying to say, what are you going to ask for us when we ask for it? So then we can be prepared and make a plan to keep moving forward with the 4 million gallons a day.
Yeah. Hypothetically, MSA wants a permit, 4 million gallons a day. DEQ, what are you going to need to see in order for us to prove to you that we can get a permit for MGD?
That's the conversation we're having now. And I think when we get to the point that we understand and get a good feel for where we think the DEQ is going, if we can't get the support to move them to having the ability to withdraw, this actually needs to be more than 4 million gallons a day, around 4.5 for an average, and then have some peaks in there. But a capacity amount of 4 million gallons a day, if we can't get that, then we're going to have to pivot and start having discussions about where we're going to get that remaining capacity before we find ourselves that we have to go get that permit and derate the capacity of the raw water intake. No, by the way, we have the failing infrastructure that we got to take care of on the raw water pump station to keep pumping 4 million gallons a day out of it. And the health department's already looking at derating that to 2 million because we don't have the 3 pumps in place. Essentially 25% redundancy, but that would give us 33.
So Jordan, the other thing I think to note, you might have said at the beginning while I was upstairs replacing some batteries, but this is the first part of potentially a 2-part. I don't know if you covered that the next look is going to be at the wastewater.
Correct. So all of this dialogue today is around the facilities assessment and talk about what we're finding on the water. When we're going to have another time where we talk about the wastewater side and what those capacities are and what those items are of getting fixed. But we are in this discussion focusing on the water facilities assessment. the intent of a lot of these discussions, this is not going to be the last time we come in front of, I'll say, our customers and the county and have the dialogue. And the intent is, as we move through the PRs and work through this, we're going to come back and have updates and try to have more of these presentations and discussions. And then we'll kind of follow that same as on the wastewater side, as that portion of it's moving, we'll come back and have those discussions as that's moving on. Have we? So the question was, have we identified alternative sources? So at the moment, I don't think we've had an extensive identify a alternative replacement water source. I think there's been in the past that there's been looks at things like the Morse Creek Reservoir of could it be an emergency scenario? But I don't think there's been a study into what an alternative water source would be. Correct. Somebody may pull something up from 1975 and wave in my face, and I'm almost sorry I didn't read that.
Moving on to the raw water pump station. So a couple slides before, I think we walked through some of the reasons why the raw water pump station should be replaced. That's our recommendation. And we're recommending that it be relocated or be located out of that 100-year floodplain. Because again, if you're going to make the investment to significantly improve and upgrade that facility, it makes, there's several reasons that it makes a whole lot of sense to pull it out of that floodplain. Next steps, prepare raw water pump station preliminary engineering report. The MSA is currently investigating funding opportunities. And so depending on your funding source, a PER is going to be a requirement. And so this is, not only is this the next step sort of in the engineering design phase, but it's also expected from a funding agency in order to secure a loan. So moving forward with that PER, we're going to look at the interconnection with that raw water intake, again, because we can't significantly modify the structure. So how do we tie into the piping and bring that to the new pump station? We'll look at some siting, preliminary layouts, pump selection, and then the electrical and controls considerations. Once the PER is done, and depending on the timeline and the planning that the MSA chooses, the next steps would be final design, bidding, and construction. Not saying that that's immediate, not saying that we're still sorting that out. I think a discussion at the end of this would be some of those funding opportunities that are available near term. For the water plant, conclusions, the existing water treatment processes, they're producing high quality finished water. But again, most of that equipment dates back to 1975. So there's some significant investment decisions that need to be made. That pre-treatment structure is in very poor condition. Continued repairs and rehab are not cost effective or sustainable. Also need to fix the hydraulic bottleneck that's reducing the actual operating capacity of the plant down to that 3.5 MGD range. Addition of deficiencies, we had the process equipment, the issues with the solids handling side of the lagoons or the sludge drying bed. I think it's worth investigating standby power to provide complete backup power at the plant instead of a quarter of its capacity. Improvements to that HVAC system on the 3rd floor, and then improvements to the instrumentation and the SCADA systems. Recommendations and next steps, similar to the raw water pump station, suggest going ahead and moving forward with PER, evaluating conventional treatment alternatives, whether that's replacing kind or going with something that's similar to what the MSA currently has, but with a smaller footprint. Right now, we're not investigating like a direct filtration or a wholesale treatment change, but that's subject to change with some of the emerging contaminants that are coming out. There may be a reason to add that to the list, but right now
emerging contaminants are new regulations and new things we need to treat for. And our current technologies do not meet those requirements. If these new regulations potentially come out and we get hit with them, there are some of those contaminants that a current water treatment, surface water treatment would not be able to treat for those, where a direct membrane or some other type of alternative source may be required.
PER would also include
So the question, I think by Mr. McDaniel was, would the water treatment facility have any type of grandfather status with these new regulations? And the answer to that is no. What ends up happening is in things like this, whether it's cryptosporidium, whether it's PFAS, whether it's any of these other contaminants that we start to, as humans and the regulatory agencies go, this affects human health. You need to now treat for that. But typically what happens is they put in a rule, the EPA does, then that rule gets transferred down to the states, which for us would be Virginia Department of Health or Virginia Department of Environmental Quality, depending on whether it's water or wastewater. And then when that then gets implemented, we would need to meet those new permit limits. And so in some of these instances, it's new limits. Some of it, they'll say, if you have the contaminant, then you have to treat for it. It all depends on the scenario. An example is the nutrient removal upgrade at the wastewater treatment plant that was completed in 2010. It came in and said, Chesapeake Bay's got an issue. All the people that discharge the Chesapeake Bay watershed have to meet these new nitrogen and phosphorus limits. Therefore, no matter your age of your facility, these are your requirements. And then they did some studies. And for us, the Moist Service Authority, they gave us new regulations. We had to implement those within a certain time frame.
And so at this time, we're not anticipating that any of these emerging contaminants are an issue that the current process can't accommodate. However, to Jordan's point, or maybe the point he made to me, Matt, if we're making a significant investment in these facilities, I really don't want to turn around and have to go and construct more facilities because of a rule change that the VDH or EPA makes that gets forced down onto us. So while we're doing this evaluation, let's make sure that we're considering and accounting for these potential contaminants before we make a final decision.
And the two I gave were PFAS and cryptosporidium are the ones we know that are there.
Well, no,
Excuse me, I apologize. We don't know that they're there, but we know that they are contaminants that are being looked at by VDH to then being regulated. Better way of saying it. I shouldn't have said they were there because we don't know for sure. Thank you, Matt.
once the PER is done, the next steps in the next step to getting these improvements done would be final design, bidding, and then construction. And so whether all of this gets done as one big project or slices are done over a longer planning horizon, not really trying to dive into that with that statement. It's just PER, final design, bidding, construction. Going to the water storage and transmission system. Conclusions: the tank's in generally good condition. There's some rehab that needs to be done on the exterior and the interior. The infield pump station's in good condition. May consider replacing the monorail with that bridge crane. We recommend developing the hydraulic model of the water transmission system. And for the MSA to continue and ultimately complete the replacement of that loop piping. So again, next steps, go ahead and move forward with that hydraulic model. Prepare a water storage and transmission system PER, and then again, final design, bidding, and construction. So this is probably the slide that most would have wanted to see right off the bat, right? But when we talk about in terms of improvements, and what's that investment look like? Planning level stage, and a few months ago, several months ago, we said it was in the neighborhood of 20 million. But, and Jay, this is a caveat that we've added to this, but because of supply chain and labor volatility, we've seen recent bids within this region 150% higher than estimates that were made 4 or 6 months ago. And so just want to put that out there for full disclosure. 20 million was a reasonable number several months ago. It's probably not a reasonable expectation in today's market.
So this is all Maury Service Authorities projects. So when you say percentage county and city, I'm not sure exactly. So I think the question is what percentage of the $30 million would the county pay? So right now, the way it works is that the Maury Service Authority actually has the loans in the Maury Service Authority's name, and in the water plant side, it goes through the rate structure. And so the way we've done it in the past is all of our debt service that the Maury Service Authority has for the systems that the MSA owns and operates actually goes through the debt service. So I think what you are going to watch as we start having rate discussions coming forward is how to, as we start to make this horizon plan, what that's going to be and how can we try to take some of that debt service into account. And I think that our next slide, one of the things that we've gotten authorized to do, the Maury Service Authority has made a decision to do, is move forward. If you look down on bullet 5 or 6 down towards the bottom, it's to go ahead and apply for the loan through Virginia Department of Health's construction, financial and construction assistant programs, FCAP. And the reason is the Maury Service Authority Board back in December, January, authorized the staff, authorized me to move forward with trying to get a implementation approach and plan, actually maybe I think back in November, to try to understand, we've got the facilities assessment. Now we got to start laying this out, how we're going to get this work done, because that's the next step once you get your arms around and get in a pile. So we started working through that implementation approach. And part of that implementation approach is, are you going to do it all at once? Are you going to do it out over 10 years, 15 years? How are we going to structure this to get this work done? Obviously, there's a lot of immediate needs, but how are we going to get that taken care of? So we had a conversation with VDH FCAP program. And in that dialogue, as part of that implementation approach, we found that because of some of the infrastructure money that was starting to get signed in on the federal level, they were looking at how that was going to get distributed into VDH and also DQ, but in this case, VDH for infrastructure projects. And one of the things that was said to us in part of that program is, if you had this larger project, instead of trying to make 3 different projects, if you were to submit those all at once, there's a significant amount of principal forgiveness. We used to call it grant money, principal forgiveness that's coming out. And there's also a significant more amount of funding that this FCAP program is getting, period. And in the order of magnitude we were hearing was there's a potential for projects to get 45% principal forgiveness, i.e. grant funding. So we took that to the Maury Service Authority Board. We've lumped these in as one project, not because that's the way we thought it was going to be done at first, but because when we heard, yeah, we could handle a $20-25 million project, where before we probably wouldn't have considered it in this financial step, they said there is a potential for that. And there's also potential for grant funding. So we moved forward, and that grant funding application is due in April. So we moved forward with this April. So here in a couple of weeks. And so we've been working on getting that application together to then have that submitted to see what it is that we might be able to get. And so that FCAP, what will end up happening is we apply, we go through a process. There's other people competing for this, so I don't want to set any promises, but you don't know unless you ask. And so what we've done is put that out, and then probably summer to fall timeframe, we should get back either you didn't get it, or some type of commitment letter for some loan. And then at that point, the MSA is going to re-look at it and go, did we get what we asked for? Just say we get the $25-30 million, we get 45% grant funding. is that the way we want to move, or did we get some other amount? And then we'd be able to reassess on that implementation approach and figure out how to then move those projects going forward.
And going back to the part of the reason the PERs are authorized is the FCAP program will need to see you need VDH approval of those PERs in order to move forward with final design. So that would be a requirement of the loan. Again, there's other funding agencies that would require it. As we started working through that implementation approach, there was this potential for significant principal forgiveness. The MSA decided to authorize getting started on these PERs so we can show and prove to VDH and FCAP, hey, look, we got the facility plans. Here's the PERs. We're ready to go. Help us with some grant or some principal forgiveness. Can you fully fund this? So then get it back and reassess. Is this the approach the MSA wants to take?
Do we want to go a different approach? Exactly right. Preliminary engineering reports. We've got 3 of them in a hydraulic model. No matter what funding happens, those are the next steps. We've got questions that have to be answered on the engineering detail level that have to help us then make the decisions on how we're going to design those systems. So that's the purpose of the preliminary engineering reports. Quite frankly, it's standard practice, no matter whether it's finance requirements or not. It's just good standard practice. At the same time, the Moore Service Authority, we've just gone ahead and approved and started. We had a kickoff meeting last week for the water storage and transmission PR. We had a meeting today, actually kickoff for the raw water pumping station PR. And I think right now we're currently scheduled next week to have the kickoff for the water treatment plant preliminary engineering report. The hydraulic model was actually rolled up in the kickoff meeting with the water storage and transmission system because they kind of go hand in hand. And so the hope is that at the moment, if the planning can keep on the pace at which we're moving, we should be at a point that we have some draft PRs in hand when we're hopefully hearing back the good news from the FCAP program and have some of those be able to move forward. So that way, if we get what we would like to have, then that could be one of the options we'd be able to move forward with. And I think also the next steps is continue to have community communications. I think the intent, as I mentioned a little bit before, was as we work through those PRs and we give the Moore Service Authority Board updates on where that is, we'll probably get to a point where we turn back around and on the water plant side, have another meeting to similar to what we're doing tonight for our customers and just talk about where we're at and where's the approach and how things are moving along.
And I guess the last thing that to sort of just come full circle, right? The work that was identified, it's not a matter of if it needs to get done. It has to get done. And it's a matter of when does it get done and how does it get done? The MSA has been making those improvements on an emergency basis for the past however many years. And so it's when it breaks, we go and replace it. When the raw water pump station fails, we would go and replace it then. And so this work, whether it gets done as part of the FCAP, it gets as one big project with 45% principal forgiveness, or it gets put on a 20-year planning horizon and is implemented systematically, the work still has to be done.
With that, any other questions that we haven't asked so far? Hopefully we didn't give you a shock. Any questions for Mr. Mullen from the remote side?
No, I've seen what you've shown us, Jordan, and it looks like you're going to be busy for a while.
Yes,
I
sir.
don't think there's any way to avoid doing the work. Like you've stated, it's just how you're going to make it happen.
Jordan, can you summarize that real quick for the record
I couldn't hear any of that.
Yes.
online? Anybody else wants to talk?
David, I apologize, don't know last name. Yeah, Mr. Reynolds, I think the comment that was made was that two big concerns that he sees is the raw water intake permitting requirements, along with some of the piping materials and other VDH requirements for redundancy. And a lot of those concerns are coming based on the planning that the PSA and the county is having to make for either growth or people coming into the community and being able to say, we have that 4 million gallons a day of water for you. And then also, I think the other point was you're currently going through a rate, system capacity study. So being able to make sure that 4 million gallons is available and what needs to be planned on. Is that a good summary?
It is, and
Sir.
I'll say this too. When we talked about this, I mean, we're looking at it, if you would, I wouldn't say globally, but in a holistic sense. And Brandy Flint is, I think she's still on here. She's listened to Economic Development Director, and we're looking at it from the point that if you're making repairs, let's look at it and see what we can do with capacity too, because Chairman McDaniel was exactly right. We need to know when we have a business that is looking, a prospect that's on the coming down from the state, and they say where they're looking for 40 acres and they need 100,000 gallons a day. We need to know that we can provide that. And we need to know what we can't provide. And we also need to, as you're looking at this, do we need to look at expansion of anything while you're looking at the repairs? So I think it's critically important for the future of the county.
And I think from the Morris Service Authority's perspective, we need that from our customers, because the Morris Service Authority can't add customers. We can't expand unless the customers are saying we need that expansion. So I think we are ready. And I think some of our dialogue that's going to be coming out of this, whether it's the discussions with the DQ or it is should we be able to, do we need to take into account a higher capacity? I think that will have to come from our customers to go, we need more than X million gallons a day.
And the other ask may be, can you help provide us with the supporting evidence, the supporting documentation, so we can take that to where we need to take it to justify that request?
You just tell us what kind of documentation you need and we'll absolutely provide it in what form you'd like it in.
Thank you. Without any other questions, Mr. Suter, does that wrap us up?
Well, yeah, alternative water sources would be a piece.
Yeah, I think if we're looking at more than 4 million gallons, the answer to alternative water sources I'm not going to, never 100% sure. I'm pretty sure the answer is going to be, we need alternative water sources. I think if we come to the point where we're going to get the permit requirements and getting a new permit for the raw water intake, our current look at it right now is we're trying to understand from the DEQ, but there's a good chance that we will need alternative water sources in that scenario whenever we go to get the permit. But until we start going down and looking into those, we haven't been told that we need more than 4 million gallons a day. And I think we also wanted to make sure that we understood what the DEQ requirements are going to be before we started going to do that. I think when we talk about alternative water sources, I don't think it's just looking at a map and seeing where water sits. There's a significant amount of work that goes involved to understand if there's a water source that's reliable to put out. If you're talking about 2, 3, 4 million gallons a day capacity, I think it's not just we've got this other pond over here that we could pull it from would that work. Most likely there's going to have to be research done into groundwater sources, which is going to involve doing physical work, drilling, running, working, having certain time period of what is that well yield, safe yield, and things of that nature. So when we start talking about identifying alternative water sources, I think the more service authority, the way we've approached is we haven't been told that we need more than 4 million gallons a day yet. And what we're trying to do is answer from the DQ, do we need to look at, are you going to give us that 4 million gallons a day coming out of the river? We're trying to prepare everybody we talk to that we're not confident that we're going to get that, but we don't know yet. So before we go spend the money on finding those sources, we want to try to get the answers. Do we need to yet?
I guess along that due diligence part, we talked about for the intake, what are the next steps? And so the DEQ discussions are the next step. We got a PER that's going to be touching that raw water pump station. And we've identified a whole bunch of work everywhere else. And so these discussions with the DEQ, right now the plan is they're moving in parallel with the raw water pump station, because if we get good news and there's we could get a permit, it would make a whole lot of sense while you're going to have construction in the area. Let's go ahead and fix the intake, fix the operation and maintenance issues that are at the intake. Because if we make a conscious decision to not touch it because of what DEQ says, that's fine. But we need to advance these discussions far enough to where the MSA is making a decision to either, yeah, we want to go fix it. And that means we're going to get a permit for a lower, for instance, a lower withdrawal permit, or we're going to consciously not touch this right now because we don't like what the DEQ is saying, and we need to continue to advance identification of additional water sources, whatever that may be, before we go and touch the intake. So that was in the white space. We didn't talk about that, but that's in the works as well. We don't want to just turn a blind eye to the intake while we're working along on these PERs.
And one more thing, back kind of the big picture of this too, we're due for a comprehensive plan update, and that all links together. And then you look at the capacity study with the PSA. It's not just how much water can we use, it's how much water on the other end of things, which is the next step. How much water can we treat, and how much water can the PSA's lines transport, both going and or coming and going. So that in the comprehensive plan drives a lot of that. So it's just some things for everybody to keep in mind.
Good, because I don't know if I'm good at reiterating the question.
Got it? Yep. So run out of timeline, Jordan. You guys talk to FCAP. FCAP says this. You're doing PERs.
Yep.
This conversation's been going on for a long time. I mean, there was a weather event a year ago that caused the conversation to get really started. There seems to be, or I think that there needs to be a little bit more intensity around it and getting going before something happens and we're, I don't know, boiling water, for lack of a better term.
So I'm glad to hear that, because I think what we've been trying to do in this is try to make sure we're getting out to the public of, we need to start moving on this with an urgency. I think the difficulty is that when you have that type of conversation and then you throw out a number of $20–30 million, that slows that urgency down significantly, which I think is why having this conversation about what needs to be done is important. So where we're at currently, I'll go ahead and talk about that for the timeline. We get the approval, FCAP comes back. We're currently on a horizon for these preliminary engineering reports that we are kicking off now, to where I'm gonna say the end of summer, fall, wintertime, they're all kind of lining up. Should be happening around the time that we're getting that FCAP funding back. We end up having a scenario where that comes back favorable, makes sense. the intent and the horizon for this is, if we're moving on a timeline, is having these construction projects completed in the FY 26 to 27 range. And so what you look at is, off the top of my head, we'd be looking at getting, with the funding, getting those approvals set up. You'd be looking at getting the construction kicking off in the 24, mid 24 annual year, a year, 2 years projects, if we did them all as just one big project and things worked out with FCAP. One of the benefits that we had put out as part of applying for it in this approach is that it's within 4 years getting this work completed. I think when we talk about, part of the difficulty that happens when we talk about this is that when you are at the point that you're having to sustainably provide clean water 24 hours a day, 7 days a week for 1,440 minutes a day, and you have failing infrastructure and equipment around you, it takes up a significant amount of the effort to try to maintain that and not lose it. And so the examples I'm going to use are these raw water pump stations. We had the pump going out. We got the parts in. It failed about 3 days before we got the parts in, went to replace the pump because of the 1975 piece of equipment. Now, during that time frame, we had to rent the diesel pump. We had to get a bigger one on site so we could keep making them water. We had superintendent, along with all the rest of the staff and the contractor, superintendent, chief engineer, executive director, all hands on deck to get that failing pump scenario worked for about 3 or 4 days before we could stop having to be involved in getting that completed. And so as you're fighting fires that way, as far as I know, there wasn't anybody that lost water at the time and had any blip on the radar. And so the difficulty is we are moving at a feverish pace. And I think right now, the fastest avenue is if we can get all of this funding and these projects done at one time. I think the difficulty is going to end up being is if we start to get to the point where the funding scenarios aren't as palatable, then you're going to look at, instead of 4 years time frame, we're looking at 10, 11 years time frame for all of those things to be able to space them out, to be able to take care of them. And on the flip side, we have the same type of discussion that's going to be happening on the wastewater. And so we're fighting the same fires with the same group of people on the wastewater side, having the same type of discussions to be able to move the same magnitude of work that we've got to move across. And I think what we're looking at is I can give as many examples as you would like, that we either had an infrastructure, something fail since 2018 timeframe that either was on the verge of a catastrophic event, or we did it 3 weeks, 4 weeks ahead of time because we saw it failing and we had to work to get it completed. So I think in the best case scenario timeline is if we could get the funding that we're looking for. Part of the reason why we authorized to move forward with these preliminary engineering reports right off the bat and not wait, doesn't matter what the funding it is because that's the immediate next step. And we've got to get that completed to then move to the design, to then move to the construction. At the same time, we got to try to figure out if we can get funding in place, including, especially with a lot of this infrastructure money that's coming down through the proverbial pipelines, to try to help that move those things faster down the court. So best case scenario, end of 2026 annual year timeframe. Any of the other scenarios, longer than that. I think when you're looking at this size of projects, nothing that we're talking about is anything less than 1.5 to 2 years of construction worth of work. And so when you look at 2022 going to 2024, you're looking at 2 years of construction work with 2 years of get the money and get the design in place. You know, one of the things that, well, I'll stop there. Hopefully that answered roughly the question.
Simultaneously doing financing, planning ahead.
Yes. So all that's moving at the same time. But I do appreciate the move faster. Unless there's more questions, we could talk about more if you'd like. But I think that's all we had planned for the presentation. Thank you all.
Thank y'all.
Thanks, Jordan. Cheers.
Okay, so the Board of Supervisors meeting is adjourned on a motion by Supervisor Lyons, second by Supervisor Day, 5-0.
All right, and
7:20.
Do I have a motion to adjourn the PSA?
Yeah.
Has anybody left?
Motion by David Reynolds.
All right, and do I have a second?
All right, you have a second?
I'm sorry, I didn't hear who seconded.
Oh, I'm sorry. Jay Melvin.
Okay, all in favor? Chair votes aye. Thank
Unanimous.
you all.
Thank you, everybody.